Students, we have completed up to third module, and our subject is sensor and transducers. In this module, we will discuss about the thermocouple. This is our module number 4. This is the module 4. Topic name is thermocouple. Thermocouple. Topic name is thermocouple. So what is a thermocouple? So are a thermocouple are a kind of temperature sensor that used to that measure the temperatures of one of a specific point in form of electromagnetic force or in current. The thermocouple sensor means this sensor to measure the temperatures into convert voltages into electrical voltages. The thermocouple sensor comprises two dissimilar metal that are connected at one junctions. The temperature can be measured at this junction, and the change in temperature of metal with wire stimulated are voltages. So we can see the diagram of thermocouple. This is the thermocouple diagram. So thermocouple like this. We can measure this is the thermocouple. Here this is the temperature T1. Here is a temperature 2. This is the metal A. This is the metal V. Metal A and metal B both must be different. This is the cold junction. We can say cold junction. COLD, cold junction. Any can be cold junction. This can be like cold. If this can be hot junction or cold junction. In this way, should we finish when two dissimilar metal are joined together? This is the metal A. This is the chromyl. This is the metal A. Name is a chromyl. This is the metal B. This is the metal B is aluminum. So when two metal, it can be hot junction or input temperature. It can be input temperature or can be when two dissimilar metal are joined together at one junctions. They form a circuit. This is the output millivolts. They form a circuit. So that's the temperature of these things can be converted to voltage. Means whether look like this two dissimilar metal A, metal V. This like a thermocouple. This is the temperature hot T1. This is the temperature T2. This is the metal A. This is the metal B. When two different metals, metal A and metal B, are joined together, so the generated voltage is directly proportional to the difference between in temperature T1 and T2. So we can generated V0 directly proportional to temperature TH hot junction minus temperature TL TC cold junction. We can say TC cold junction. And when we can remove this proportionality, so one constant will come. So we write this constant V0 output equal to S into delta T. What is the delta T? Temperature of hot to delta T is nothing but delta T is equal to TH hot temperature minus TC cold temperature. S is a sensitivity constants which depend on the materials that is used, metal A and metal B. So this is the completely depend on the used material. Used material. So this is the thermocouple definition we can see here, and that amount of voltages which V0 is equal to S into delta T, which we have seen. The amount of EMF generated in thermocouple is very minute. This range is a millivolt. This range is a millivolt range. And very sensitive devices so must be utilized calculation for electromagnetic force circuits. The common devices that to calculate the EMF or voltage balance is a balance potentiometer. The common devices that used here, the balance potentiometer, ordinary galvanometer. We can use ordinary galvanometer for these are balancing potential utilize the basically physically or mechanically. Next we can see the working principle of thermocouple. Thermocouple mainly depend on the three working principle. First is a Seebeck principle. First is a Seebeck, second is a Peelter, third is a Thomson. Three working of thermocouples depend on the three things. So what is the definition of Seebeck? What is the Seebeck? We will see the what is the Seebeck. In the Seebeck type thermocouple of effect occurs when two dissimilar metals when they heated offer to any one of metal wire, the flow of current supply from the hot metal to cold metal, and then the flow of current apply from from the supply from hot. Suppose two dissimilar metal, we can understand, we can try to understand this. This is the two different metal A, metal V, metal. This is the hot junction temperature. This is the metal A. Suppose that this is the metal B. This is the cold temperature C. When when two dissimilar matter are joined, so current flow from the high temperature to low, the direction of current from the high temperature to low temperatures. This facts tell that when two dissimilar matter are joined, between the hot junction and cold junction, so the current will flow from the high temperature to low temperature. This effect has given by the CVAC from the hot metal, and then the electrons flow, supply from the hot metal to electron supply from the hot metals means electrons move from here to here. There's a movement of electron hot metal to cold metal. So this effect was given by the CVAC. CVAC simply said that when two dissimilar matter are joined together to form a junction, the flow of current from the supply of current from the hot metal. Next, what are the Peelter effect? We will see the Peelter effect. The Peelter effect is opposite to the CVAC effect. This effect states that the difference in temperature can be formed among any two dissimilar conductor by applying a potential variation among them. Suppose that Peelter just tell to oppo- opposed statement to the this is the temperature T1, this is the temperature T2, this is the metal A, this is the metal V. According to this effect, said that the temperature differences delta T, temperature differences delta T can be formed any two dissimilar metal applying a potential means S This is the voltage. Suppose this is the sensitivity. So if we apply the potential to the sublimiter by applying the solar conductor by applying a potential, if we apply potential between the two conductor, so we can form the temperature on this according to this is the filter effect. Thomson effect. This effect this effect states that two this separate metal fixed if they form a joint together voltage induced on conductor length due to gradient temperatures, and this is a physical will demonstrate the direction of temperature exact. According to this expression, when two dissimilar matter are joined together like this, temperature T, temperature, the current start from here to here, will electron from here to here. So according to this statement, that this is a conductor length due to temperature gradient. Temperature here to here, gradient of temperature. Temperature will change. If the high temperature is here, low temperature, temperature gradient can be produced according to the Thomson effect. Second construction of last is a second is a construction of thermocouple. So thermocouple construction are shown. We can show different way. It comprises two different metal wire that are connected together at a junction. The junction things is a measuring end, and that end is classified into three types, namely grounded, ungrounded, exposed. Based on the construction, this thermocouple are classified three type of concept. Pehla, grounded, based on the construction, grounded, ungrounded, and exposed grounded. So we will see based on construction each. First is a ungrounded. In this junction, the conductor are totally separated from the protecting cover. Application of junction mainly due to high pressure application works. The main benefit using this to decrease the electromagnetic field. So we need to when we need to decrease the electromagnetic field, we can use this stray somewhere so electromagnetic field that affect the performance of the second is a high pressure means the conductor are totally separated from the protecting devices. Suppose this is the protecting devices, इससे conductor are totally separated होता from the protected devices से. That's this type of ungrounded connection. Second is grounded connection. In this type connection, metal wire are well protected and covered together. The function is used to measure the temperatures, acidic atmosphere and its supply to resistance noise. When we want to measure the temperature in acidic atmospheres means we need the grounded tension and supply resistance to noises. Metal wire are protecting cover connected together. Second, previously we are using for pressure measure, high pressure measurement. That second one we learn temperature measurement for. This is the our applications work. It reduce the electromagnetic field. Second thing, it reduce the electromagnetic field. Grounded. This is the use for this measure the temperature, acidic and power supply. This is the again we are doing. Last is the exposed junction. Second is the exposed junction. Exposed junctions. Exposed junctions is applicable area where the quick response is required. Quick exposed junction generally where we need the quick response. This type of used to measure the gas temperatures. Gas temperature. The metal are made with thermocouple basically depend on the calculator. For gas, for measurement of gas temperature, we need to exposed junction type thermocouple. For measurement of grounded, for grounded use to measure the temperatures in acidic atmospheric level, and this is ungrounded in this type junction. generally used to high pressure application we can use this. We have discussed three thermocouple grounded based then. Generally thermocouple are designed with two different metal wire, namely iron constantan. Generally iron constantan make detecting element connected alone. Those are working principle, how they are working. So the working principle of thermocouple. The thermocouple systematic diagram shown below. This circuit can build two different metal. Suppose that this is a two different metal. This like this metal A, metal B. This like this is the metal A. This is the metal B. Hot temperature, cold temperature. So like TC, cold temperature. This is the general form of thermocouple. And coupled together, generating two junctions. Two metals are surrounded by connection through welding. This here building is two metal AB is hot junction, cold junction. This is the man. Based on this diagram, we can see the hmm. This is the measuring junction. This is called hot junction. Hot junction. This is the called a cold junction. COLD, cold junction. This is the voltmeter. This is the metal A. This is the metal B. Two different metal. If same metal is there, so no same voltage, it gives the same reading here. So this here, when two metal are joined together, if the temperature when two metal are joined together, they have different temperature. Electron flow from high voltage, from high temperature to low temperature, it creates the voltage. It creates. If the temperature at the junction, at the end of the junction, turn equivalent to, it will reverse electromagnetic force produced. So no current flow through it. Similarly, temperature at the junction end become to imbalance and physical variation include the circuit. Means if if temperature, cold temperature and this is the hot temperature are equal, there is no current flow from here, so that sensitivity into delta T, so voltage become to zero. The electromagnetic EMF produced by, we can write equal to A is a constant, delta theta is a temperature change in temperature, plus B is a delta theta square, where theta is temperature differences among the thermocouples. Age as well as reference in hot or cold junction. Sometimes we can measure thermocouple junction or reference junctions. AV are the constants. So what are the advantage and disadvantages of thermocouple? पहला, high accuracy. Thermocouple has very high accuracy. Accuracy of thermocouple is very high. It is a robust that can be used to environment like temperature, high vibration. दूसरा, wide temperature ranges is there. दूसरा, cost is low, extremely constant. Disadvantage, low accuracy. दूसरा, thermo recalibration is very hard. Applications, thermocouples let they are used they are used as a temperature sensor in thermocouple homes and offices also. These thermocouples are used in industry for monitoring temperature, metal, iron. Second, these are used to These are used in food industry, cryogenic or low temperatures. These are all thermocouple used in chemical plants, petroleum plants. In this way, we can see the thermocouple. Our next class we will discuss the different type of thermocouples.